Hello, physical science. This is Miss Ruark, and we are starting off our entire school year by watching this vodcast, which gives you your notes at home. And the nice thing about it is you can watch this over and over and over again. You can pause me. You can rewind me. You can watch me in bed. Not watch me in bed, that sounded bad, but you can watch this while you're sitting in bed in your pajamas eating a bowl of popcorn. It's like being at the movies. Woo! And you're doing your homework. It's excellent. All right, so let's start this physical science off. We're going to start off with a little bit of the basic math, and we're going to talk about rounding and the difference between accuracy and precision, because those are misused a lot. All right, so why do we round? Well, with science and even math, to make sure that our answers show the amount of accuracy that we need and the amount of precision that we need, we use a thing called significant figures or significant digits. And these are used to show the accuracy of the measurement and the equipment. It shows how precise the equipment can be. Okay, so if you see this, it looks like a centimeter side of a ruler. Okay, and this, normally you would just see the 12, the 13, the 14, the 15, and then you see these teeny tiny lines in between. Well, if we blow that up a little bit bigger, you still see the 12, the 13, the 14, the 15. And then in between you have the little lines. And if you count those, it would be 13.1, 13.2, 0.3, 0.4, 0.5 is the long one, 0.6, 0.7, 0.8, 0.9, and then you'd have 14. Or 14.0. Well, and I don't have it on here. I probably should have, though. You can actually take these here in between those two lines and blow it up again and pretend like there's a long 0.5, and so you would have 1, 2, 3, 4, 1, 2, 3, 4, and then the next would be, so this would be 13.30, 13.35, 13.40, right? I'm using my mouse, so I apologize, but 13.4. All right, so when you're reading your measurements, you always want to read with the correct number of significant figures, which gives you all numbers that you know for sure, and then one number that you're guessing. And the guess is an educated guess. You don't just put a number in there. You make an educated guess or estimate. Okay, well, we're not going to worry too much about significant figures, but you do need to know how to round. And I put this in here so you would know why we round. So what I'm going to do, actually, here is another picture, sorry, that gives you a more detailed information, gives you a little bit more information on it. And it shows you that if you were to measure this crayon in inches, this would be 2, this would be 2.5, this would be 3, so it would be, oops, my line went a little skewed. It would be around here, so I'd say it's probably about 2.8 inches, but I don't know the 8 for sure, so I can't say anything more than that. And then on this pencil here for the centimeters, the tip of this pencil comes right there. Well, look, it's not quite 16 centimeters, so I can't say it's 16 centimeters. I have to say that it's 15 point, and I make an educated guess, so I'm going to say 9. But because that last digit is an unknown digit, it's a guessed digit. So I can't say if it's right or wrong if you say it's 15.8. Now, if you say 15.84769, no, that's incorrect. You can only guess one number. So 15.9 is correct. 15.92, incorrect. Okay, just that one after it. All right, so we need to know how to round because I'm not going to tell you to learn. There's lots of rules for significant figures, and we're not going to worry about those. But I do want you to know the rules for rounding. Okay, rounding has not changed any since you learned it in elementary school math. So let's go on ahead and practice. If we have this really long number, 250.08756, and we want to round this number to the hundredths place, which is 2 numbers after the decimal. Okay, so rules. We find the number we want to round, that number right there, and we're going to draw a line to it. And this is how I do it. And I put a line up. I do it this way every time. Even though I don't need to, I still do it this way every time so that I can show y'all the proper way to do it, because if anybody's stuck, they can follow what I'm doing. All right, and then we want to look at the number directly behind the line that we drew, and that would be the 7. All right, so if that number, this right here with the blue arrow to it, is a 5 or higher, so 5, 6, 7, 8, 9, the number in front of it will go up by 1. If the number that the blue arrow is pointing to is below 5, so it's a 0, 1, 2, 3, or 4, the number in front of it does not change. So is this 7 going to make this 8 change? And if you said yes, you are correct. So it would be 250.09. Okay, we don't look at any of the other numbers behind it because they don't really matter. All right, that was easy, right? So I want you to try these. Okay, round the following numbers to the number of decimal places indicated by the parentheses. So the number after the parentheses, we want 1. Okay, I'll do the first one with you, and then I want you to pause it and try 2, 3, and 4. All right, so we want one number after the decimal, so we're going to make our line to one number after the decimal, which I think I've already got it in there. There we go. And we're going to look and see, does this 7 make that 4 go up? And if you said yes, you're correct. All right, so what I want you to do is pause. I want you to try 2, 3, and 4, and then come back and check your answers. All right, number 2, we want 2 numbers after the decimal, so we're going to draw our line to 2 numbers after the decimal. Does the 5 make the 2 change? Yes, 0.03. All right, this one we want 3 numbers after the decimal, so we draw our line. Does the 5 make the 4 change? And if you said yes, you are correct again. And there we go. And then for this last one, we need 5 numbers after the decimal. So we're going to draw our line. We want 1, 2, 3, 4, 5 numbers after the decimal. So we're going to draw our line. And does the 2 make the 1 change? No. The 2 is not a big enough bully to make that 1 change, so it stays 0.01541. Okay, and remember, if I'm going too fast at any time, you are more than welcome to pause, rewind, and rewatch. Okay, let's talk about accuracy and precision. So, accuracy and precision are 2 words that are used as if they mean the same thing, but that's not true. Okay, accuracy gives us a description of how close a measurement is to the true value of what we want. And precision just talks about the exactness of a measurement. It also talks about the consistency of a measurement. So let's look at this visually. Okay, here is a dartboard with a bunch of X's on it. So let's pretend like we're at somebody's house and we're playing darts. Okay, if you don't like darts, then let's pretend like we're playing cornhole. Okay, it's kind of the same thing. You're just not using pointy things to throw at someone. Instead, you're using a corn-filled bag, right? Okay, same thing. All right, here we're going for the bullseye, or in the case of cornhole, you're going for the nice circle at the top, right? You throw all of your darts, or you throw all your corn bags, and you hit that bullseye every single time. Well, the bullseye was the desired target. So we have high accuracy because we're close to the true value, and we have high precision because we hit that same spot every single time. Everybody likes to be that person right there, right? Okay. Here, in this next one, remember, we're going for the bullseye, but we hit them all over here. Now, if you're playing darts, that's not bad. Hopefully you're going for those numbers there. If you're playing cornhole, we hope that it all landed on the board and they didn't get knocked off onto the back of the board, you know, on the ground, so you lose all those points. Okay? Were you accurate? Did you hit the number you wanted? No. Were you precise? Were you consistent? Yes. All right, so you have low accuracy but high precision. All right, next one. We go back to throw those again. Remember, we're going for the bullseye. Okay, we get 1 in the bullseye, and the rest of them kind of fall around the circle. And you know who that person is when they're playing cornhole and they toss it and it just kind of lands all around the hole, but it doesn't go in. Okay, they have high accuracy because look how close it is to the hole or the bullseye, but their precision is horrible because they're all over the place. All right, then comes Miss Ruark, and she is one of the most fabulous dart players you've ever met in your life. And she gets up and she starts throwing these, and look at all these all over the place. It's like a hot mess, right? Okay, I play cornhole about the same way too. No, I'm joking. I don't. I'm really good at that. But anyways, that's another story. Okay, so we're tossing these beanbags in, or these darts, and I'm looking for this right here. But I'm real short, and I'm all skewed, so I can't hit that bullseye. So do I have good accuracy? And the answer is no. It's extremely low accuracy because they're not anywhere close. There's one. That's it. What about my precision? Have I been able to hit that every time? No. Miss Ruark needs to go back and practice, right? Okay, so that's how you can tell the difference between accuracy and precision. Accuracy is hitting the bullseye, and precision is doing it consistently. Okay, so how about if we look at this in terms of mathematical or numbers, right? So we want to know, is 2000 more accurate than 1383? Okay, these are the two numbers we're comparing, 2000 and 1383. But the number we're trying to hit is 1826. What do you think? Remember, accuracy is how close you are to the true value. So which one's closer, 2000 or 1383? If you said 2000, you're correct. 2000 is going to be more accurate than 1383. Okay, but then the next question is, which is more precise? Oh, well, Ms. Ruark, you just talked about precision in terms of consistency. We don't have any, these aren't consistent. And that's correct, it's not consistent. But 1383 on this one would be more precise because it's more exact of a measurement. It has more numbers in it. And this one's very vague. Okay, so that's two ways to look at accuracy and precision. All right, let's practice here. If we were looking here, don't cheat. Don't look back at your notes. If we were looking here, which one would this be? Would this be accurate, precise, both, or neither? And if you said precise, you are correct. Woohoo! All right, what about this one? Accurate, precise, both, or neither? Well, we could say it's accurate, but these aren't really near anything. So I'd actually say neither. But if you put accurate, okay. Okay, on this one, I would say both. Okay, accurate and precise. And then on this one, what do we got? Well, this is Miss Ruark playing. She needs to practice still. She hasn't done very good. Okay? All right. Oh, I got to clear all that out. All right, a measurement was taken 3 times. The correct measurement was 68.1. Figure out whether the set of measurements is accurate, precise, both, or neither. So on this one, it's all over the place. So it's going to be neither. On this one, 68.1, 0.2, 0.0, this one is both. It's accurate and precise. Okay, this one is all around 98, but our true value is 68. So it's going to be precise, but not accurate. And then this one here, it's kind of close to the number, but it's not real consistent. So we would say that this is accurate. Okay, hopefully you got a little bit more, a little better of a feeling about this. And when you get to class tomorrow, we're going to practice rounding. We're going to practice accuracy and precision as well. Okay, so here's a little something to leave you with. Don't be afraid of math. Numbers are your friend. All right, I'll see you in class.